Hi, we're going to continue moving along. After the substitution method, we go into the elimination method. So we're still looking for the same type of information. It's a linear system of equations. So I have two lines that cross at a point, and I'm trying to find what that point is. With the elimination method, we don't have anything that looks like y equals, for example, 3x plus 2, or x equals 2y minus 3. Whatever the situation is, there's nothing that's isolated in the elimination method. So that's why we use this method instead of substitution. Usually we use whichever one is easier for us. However, technically both can always be used. But again, we go with convenience. So with the elimination method, we're using addition or subtraction to eliminate one of the variables. In systems of equations where the coefficient, remember the coefficient is the number in front of the variable, the number being multiplied with the variable, the coefficient of the x or y terms are additive inverses. So real quick, we'll talk about additive inverses. Additive inverses are those things that equal 0. So for example, when I have an equation, I'm adding 3. We always get rid of it by doing the opposite, which is subtracting 3. Well, a positive 3 and a negative 3 are considered additive inverses. Okay, and it works the same way with variables. I could have this same exact thing, but with variables. So I could have a positive 3x, and then we always take that to the other side by doing the opposite, which is negative 3x or minus 3x. So these are also considered additive inverses, since they're opposite numbers or opposite adding numbers. Okay, so that's what that means. So the coefficient, so the number in front of my variable, are additive inverses, which means we have a positive number and then the negative of that same number so that they can equal 0. So we're going to solve the system of equations by adding the equations. Because one of the variables is eliminated, this method is called the elimination method. And when we say eliminated, we're saying that it equals 0 or that it cancels out. Okay. All right, so here's an example of using elimination to solve the system of equations. X minus 3y equals 7 and 3x plus 3y equals 9. So notice that here my x and my y are both not isolated, so I actually have to do a little bit of work here. X minus 3y equals 7, 3x plus 3y equals 9. There's nothing that I can substitute, so my best bet is to see if I can easily eliminate some variables to solve it. So we're just going to add the two equations. So we're basically combining like terms. My x's get combined with my x's. My y's get combined with my y's. Usually, because this is called standard form, where we first write our x and then write our y. Standard form because this is how we write math most of the time. And on the other side will be a number. Usually you don't have to move anything around, and your x's will be already lined up, and so will your y's, and so will your numbers. So all you have to do is actually add them or combine like terms. Okay, x plus 3x is 4x, negative 3y plus 3y, they're additive inverses, so that is 0. On the other side, 7 plus 9 is 16, so 4x plus 0 is just 4x equals 16. And as always, my very last step is to divide. Divide by 4. 4 divided by 4 is 1, so I get x 16 divided by 4 is 4, so I get x equals 4. And the same idea that we had before, we're just going to go ahead and substitute my x into my y. Alright, as I've stated before, you can always substitute this x back into either equation, because this point x comma y is a point that exists on both of these lines. That's why they cross at that point. So again, you just choose whichever one has the least ugliest numbers, or whichever one you think will work out a little bit nicer, but it does not matter because you're going to get the same exact answer with either of those equations. So they went back and substituted 4 for x in one of the equations, one of the original equations, and solved for y. In this case, they used the first one, so they used x minus 3y equals 7, and they substituted my x with 4, and everything else is written the same, so 4 minus 3y equals 7. And we always want to isolate my variable, isolate my y. So they first got rid of what's furthest from the y, which is that 4. And since that was a positive 4, they subtracted 4 on both sides. So they subtracted 4 with an additive inverse that got rid of it, so that equaled 0. And then on the other side, they subtracted 4 and got 3. Okay, and then drop down the negative 3y. Please remember that that negative still belongs to that 3y, and you always drop it down with it. Once we drop down that negative 3y, we have negative 3y equals 3. And the very last step, as always, is to divide by negative 3. Sorry, I don't know why they didn't write that in there. That's what I get for trusting the internet. Alright, so a negative divided by a negative is positive. 3 divided by 3 is 1, so I'm left with 1y. And that equals whatever 3 divided by negative 3 is, which is negative 1. Because a positive and a negative is negative, 3 divided by 3 is 1. Alright, so just as before, we now have my x and my y. All I have to do is write that as a point, x comma y. Alright, great. Let me do one more example, and then you will do one on your own. Remember, since this is a video, you can always pause at any moment that you need a little bit of help or you need to take some notes. Okay, so use the elimination method to solve each system of equations. Again, we use the elimination method because my x and my y in both equations are not isolated, so they're not ready to be substituted in either one, so I can't really do anything with that. Alright, so for elimination, when it's already set up for you, we just go ahead and make sure that our equations are written nicely, and we go ahead and combine our like terms. But the very first thing to notice is, are they actually going to eliminate? Alright, so the elimination method means nothing if a variable isn't actually going to get eliminated. And when we say eliminated, we mean that we have it equals 0 when we combine it. So let's look at this x. The coefficient is 2 at the top and 3 at the bottom. That is not going to eliminate because they're not even the same number. So now let's go to the y. The y has a 2 at the top and a 2 at the bottom. Okay, so maybe they will eliminate because they do have the same number. Now we have to make sure that they're different signs so that they end up getting subtracted to equal 0. Well, that's a positive, that's a negative. So then this is ready to be eliminated. If it's ready to be eliminated, we move on. We go ahead and add all of this stuff together. Alright, so starting with our x's, that's a positive 2x plus 3x. So positive 2x plus 3x, that's just going to be 5x. A positive 2y minus 2y, again, different signs, so they get subtracted, and I end up with 0. Which is exactly what I want. I want them to be eliminated. On the other side, we have a negative 2 and a positive 12, so that's negative 2 plus 12. Different signs, so we're going to subtract. 12 minus 2 is 10. Keep the sign of the bigger number, which is 12, so that's going to be a positive 10. Okay, let's simplify this. 5x plus 0 is just 5x, which is what we want. We don't want any more y's involved here, or any two variable equations. We just want one variable. And now we have 5x equals 10. The 5 is next to the x, so it's being multiplied. We divide by 5. Divide by 5. And as always, 5 divided by 5 is 1, so I'm left with 1x. 10 divided by 5 is 2. Those were both positive, so that's still positive. And so that's just x equals 2. Okay, once we have x equal to 2, we will choose one of our equations. Again, does not matter which one, so I'm just going to pick the top one. So 2x plus 2y equals negative 2. Make sure you're writing that exactly the way it was written at the beginning. Since I'm substituting my x, I can only replace x values. My y I cannot replace. I don't know anything about the y. So I'm going to rewrite this with my parentheses instead of my x. So 2 parentheses, and then everything else stays the same. 2y equals negative 2. Notice that there's no more x's here. If there were, I would also be replacing those x's, but there's no more x, so that's all I have to do, one set of parentheses. Right, inside those parentheses will be my number, x equal 2, so that's what it gets substituted with. And then we just simplify. So again, remember that we are solving for my y. I need to get my y by itself. But we always want to make sure that we're distributing or multiplying first and then combining like terms. So first things first, 2 times 2 is 4. Drop everything down, plus 2y equals negative 2. There's nothing else I can do here, nothing else I can do here, so I move on. Need my y by itself, so I need to get rid of that 4. Get rid of 4 by doing the opposite. That's adding 4. I know it's adding because I see that that's a term, since it's being separated by that plus sign. And it's a positive 4, so that means I'm adding a positive 4. So let's subtract it. Subtract 4 on both sides. 4 minus 4 is 0. Drop down the positive 2y, and negative 2 minus 4, these are same sign, so I have to add. 2 plus 4 is 6. Negative, keep the sign of the bigger number, so that's that 4, it's going to be negative. 0 plus 2y is just 2y, so I have 2y equals negative 6. Get rid of that 2, which is being multiplied, by dividing it. Remember, always last step is going to be to divide. 2 divided by 2 is 1, so I get 1y, or just y, equals negative 6 divided by positive 2, different sign, so that's negative. 6 divided by 2 is 3. Alright, now that I have my x and my y, here's my x, here's my y. We go ahead and put that in each spot, x, comma, y. It's always x, comma, y. So that's going to be 2. comma, -3. So at the point 2 comma -3 is where these two lines will cross. All right, let's go ahead and you try number 2. Again, this is a video, so pause this if you did not get to write that all down or if you were just listening. So now here is number 2. Okay, and since you can't actually go back on the video, let me just, this is your moment to pause if you need to write any of this down. Okay, so now we have number 2. So there's our number 2. My x and my y are not isolated, so then that means instead of substitution, I want to see if the elimination method works out. So let's look at the numbers in front of my x. Will those eliminate? So are those additive inverses, which means are they opposite numbers of each other that will equal 0? And if those aren't, then you look at your y's. Okay. Go ahead and try this out. Remember that if they are going to eliminate or cancel out, then you can go ahead and start combining like terms. All right, after you do that, let's go ahead and look at the example if you did not get it right. So that's going to be, so I'm looking at my x's and my y's. Only my x's are additive inverses of each other, which means that they're opposites of each other. So that's a +4 and that's a -4, so I know they're going to eliminate each other. So I'm good to go and I can start combining my like terms. +4x minus 4x, eliminate, and I get 0. -2y plus 4y, so now I just have to do the math here. They're different signs. So I'm going to subtract. 4 minus 2 is 2. Their common term is y, so I keep that. And keep the sign of the bigger number, so that's positive. On the other side, we have -1 minus 2. These are same sign, so I'm going to add. 2 plus 1 is 3. And keep the sign of the bigger number, so that's going to be -3. 0 plus 2y. Remember, we eliminated it for a reason, so I'm actually just left with 2y, which is great. And I just have to divide. So I'm going to divide by 2, divide by 2. Okay, 2 divided by 2 is 1, so I'm left with 1y. Negative divided by a positive is negative, and 3 divided by 2 is 1.5. Now you can type this into the calculator, or you can actually leave it as a fraction, -3/2. Okay, both of those answers are correct. Alright, so again, this is just my y value. So all I know is that y equals -1.5. I don't know my x yet, so I need to go back and substitute into one of these equations. Does not matter which one I choose, but I'll just choose the first one. You can always choose the second one. There's nothing stopping you from doing that. So I'm substituting my y, so that's going to be 4x minus 2, whatever y is, equals to -1. Okay, my y was equal to -1.5 or -3/2. If you like working with fractions, you can keep the fraction. If you like working better with decimals, you can keep the decimal. No right or wrong way to do that. Okay, so now here's my equation that I can solve for x. But before I do that, before I isolate my x, I want to make sure that everything is simplified. So first we need to multiply. -2 times -1.5. Negative and a negative is positive. 2 times 1.5 is actually 3. Drop everything else down. So I already distributed or multiplied. Now we need to combine like terms. These are not like terms, so there's nothing I can do there. But these are like terms, but they're not on the same side, which means I need to get them on the same side. So as we've been doing, here's my variable. Let's get everything on one side. So that means I'm going to get my 3 on the other side first because it's not attached to my variable. So that's adding 3. I'm going to subtract 3 to get rid of it. Positive 3 minus 3, additive inverses means they equal 0, just like in our elimination method. Negative 1 minus 3, same sign, so I add. Keep the sign of the bigger number, and that's going to be negative 4. Drop down that 4x. So 4x plus 0 is just 4x. And 4x equals negative 4. Very last step, get rid of that multiplication by dividing. 4 divided by 4 is 1, so I'm left with 1x, or just x. Negative divided by a positive is negative. 4 divided by 4 is 1. And there's my answer, 4x. Alright, so again, you want to make sure that you're always doing your x, comma, y. Every single time. So it does not matter which one you found first. It's always going to be your x, comma, y. That's how we label points. So my x value, comma, y. So this line crosses at negative 1, comma, negative 1.5. Alright, so that one was a little bit of option if you wanted to stop the video and try it. Go ahead and pause right now if you need to write any of this down. Go ahead and pause this video if you need to write any of this down. Moving on to number 3. Go ahead and try this one on your own. So this is going to be a, just so that we're clear, this is a positive 1. And at the bottom, that's also a positive 1. Remember, we always have those invisible ones whenever we don't see a number right away. Okay, and then for my y's, it's the same thing, but this one I have a negative 1 and a positive 1. Okay, so see if any of them are ready to be eliminated. If they are, go ahead and combine your like terms. Go ahead and try that now. Alright, so if you tried that, we can go ahead and look at this again. So now we have a positive 1 and a positive 1. Those are not additive inverses. Remember, inverse means that they have to be opposite and they have to be the same number. But that's a positive 1 and positive 1. Those are not going to eliminate. For my y's, I have a negative 1 and a positive 1. They both have the number 1 and they're opposite signs. So yes, they're going to eliminate. They're additive inverses. Okay, so a positive 1 plus 1 gives me 0. So those eliminate and I just have 0. Go ahead and combine the rest of your like terms. A positive 1x plus 1x. Now you have 2x. A positive 2 on the other side minus 3. Different sign, so I'm going to subtract. 3 minus 2 is 1. Keep the sign of the bigger number, which is that negative 3, so that's going to be negative 1. 2x plus 0 is just 2x, which is what I want, and then that's a negative 1. Okay, we're going to go ahead and get rid of that 2 by multiplying and divide by 2. Or sorry, that 2 was being multiplied and we get rid of it by dividing. 2 divided by 2 is 1, so I'm just left with 1x, or just x, and x is equal to negative 1/2, or negative, because positive and a negative is negative, 1 divided by 2 is 0.5. Okay, as always, let's go back and take this x equals 0, negative 0.5, and substitute it back into an equation. Does not matter which one, but I'll just do the first one. So I'm going to replace my x. So the x is going to have parentheses minus y equals 2. Again, I can only replace my x because that's the only number I know. Inside those parentheses is going to be negative 0.5. And we go ahead and start solving. Alright, these are parentheses, so I always want to multiply or distribute whatever number's on the outside. When you don't see one, that's just a 1. So 1 times negative 0.5 is still negative 0.5. Minus y equals 2. Alright, we go ahead and solve this by solve this by isolating my variable, which is my y. So let's get rid of that negative 0.5 first, because that's further. So I'm going to add 0.5. Notice that I'm still doing additive inverses. Add 0.5, and that negative and a positive means I subtract, so that's how I get 0. Alright, drop down the negative y. Again, make sure that you're dropping down the entire thing. Can't forget about that negative. That is important. And then on the other side, that's a positive 2 plus 0.5. Line up your decimals. So that's 2.5. Now we need to get rid of that negative. Remember, that's a negative 1 being multiplied with y. So I'm going to divide both sides by negative 1. Divide by negative 1. And then this will be a positive y, 1y. And on the other side, I have a positive and a negative. It's negative. 2.5 divided by 1 is 2.5. Alright, so here's my points again. X comma y. So x comma y. And if you're comfortable with fractions, that would have been negative 1/2 comma negative 5/2. Okay. Since I am talking about a graph, so for graphing purposes, I would probably do decimals so that I know exactly where this point is. Like I know that this point is at negative 0.5 comma negative 2.5. So just keep in mind that sometimes we use decimals because that's easier, and sometimes we have to use fractions because that's more convenient for us. Alright, last example that I will let you try on your own is this one. Alright, again, first check that these will be eliminated. So look at your numbers. My x's, are they going to be eliminated? If not, then you check your y's. Are those additive inverses that are going to get eliminated? If so, then you can go ahead and proceed and do your elimination method. Okay, go ahead and try this one, see if you get it right.